Hi everyone, this is Manas, your friend and tutor, and welcome to another session on deflection of beams. The method that we'll be applying, well, it's going to be MACAULAY's method. तो चलो देखते हैं इस particular problem को कैसे MACAULAY's method के जरिए how we can actually frame the slope as well as deflection equation using the MACAULAY's approach for this particular case. And it's a combination. There is a point load at C and there is a UDL for 2 meters of the span from the right hand support, right? So the first thing which we need to do immediately is to calculate the value of reactions. Let's say that the reaction over here, that is, let's call this simply RA, and let's say this is RB. How do you calculate the values of RA and RB? It's quite simple. You just need to do this. Summation of all the forces in y direction is equal to 0. So R and RB are upwards. So RA plus RB, whereas these two fellows are downwards. 20, so it's going to be minus of 20. And now this is also downwards, so a negative sign. Just take a look at this. 10 kilonewton per meter. That means in 1 meter, the load acting in the downward direction is 10 kilonewtons. So for 2 meter, it will be double, that is 20 kilonewtons. It's that simple. So simply you need to write 20 over here. And yeah, that's it. It's equal to 0. So now you have an equation in RA and RB, and that essentially is equal to 40. One equation. We need one more equation to get the value of, or to get the individual values. How can that be achieved? Well, again, it's going to be very simple. Baby mechanics, as I always say, take the moment about any point. Let's say point A is equal to 0, right? In textbook, they usually write take the moment about any convenient point, so that the equations are easy to work with mathematically. चलो यहाँ पे देखते हैं. तो we're going to start from here. RB upwards with respect to point A. RB is upwards. That means anti-clockwise. So RB multiplied by this much. That is 4. Okay, that is 4. 1 plus 1 plus 2. 4 times of RB. What else? Then what you have is this load. If you watch carefully, यहाँ पे अलग से बना के दिखाते हैं आपको. This is the beam, in fact. And there is a point load over here. कितने का ये? This is 20 kilonewtons, and then this is going to be point D, and then there is this UDL, and then we have over here. This is RB and this is RA. So if I were to replace this uniformly distributed load with a point load, well, that replacement can be done. वहाँ पे करना क्या पड़ेगा आपको? The total load acting in the downward direction because of this UDL is 20. We know this. 1 meter it's 10. So for 2 meters, it is going to be 20. And that 2 meters is going to act exactly in the downward direction. Okay, 20 kilonewtons is going to act exactly in the downward direction. So you can actually replace this UDL with a sort of point load, you can say this. And this is going to be acting exactly this much. This much is 2. So half of that, this is going to be 1 meter. Right? That's 1 meter. And that's going to be, again, this is 1 meter. So in totality, the distance is going to be, this is 1 meter, this is 1 meter, 1 plus 1 plus 1. That is going to be 3 meters. So here we go. So because of this UDL, at point A, the moment is going to be equal to 20 multiplied by this much distance. That is 1 plus 1 plus 1, that is 3. So this is pretty simple. Minus, it's going to be clockwise, isn't it? Clockwise. 20 multiplied by 3. Okay, और कुछ है क्या? Is there anything else? And we've got this 20 also. 20 multiplied by 1 clockwise, so minus of 20 multiplied by 1. So this is going to be fairly simple. 4 times of, well, obviously it's equal to 0. 4 times of RB is equal to 60, 16, 20, 80, and RB is going to work out as 4 2 is 8, 0, 20 kilonewtons. If RB is 20 kilonewtons, RA, just put this over here. RA will be 40 minus 20, that is again 20 kilonewtons. Now we know very well what the values of RA and RB are. It's very simple, isn't it? So let's write them. Let me make a separation line. That's the question for you. And these data have been given to us, guys. The Young's modulus of the beam's material, right? Steel, obviously, and its area moment of inertia also has been given to us. Let's approach this. Now we've got the values of RA and RB. So RA has worked out as, let me see, kitna? 20 kilonewtons. And RB has worked out as, well, this is also 20 kilonewtons. Amazing. Both of them are same. Okay, I'm gonna be rubbing all of these things. So if you wanna make a note of this, pause the video and do that. Okay, don't worry. I'll be providing the notes in the description, PDF format. Download that also. Okay, so that's done and dusted. Now, after working out the reactions, we immediately need to do a section and we have to frame a moment equation. Let's see how that will work out. Here we go. Section from left. Now guys, one thing which you need to remember, you need to pick up an origin, and as always, I always choose the leftmost end of the beam as the origin. Isko origin lenge, right? This is going to be picked up as the origin. Let me write this origin over here. That is this A. Okay, and from here on, the value of x will increase, and the equations will also be framed in this manner. Okay, so section from the left. Section from the left. Let me tell you something, that if you do the section, let's say from here, so let's say we cut the beam somewhere here, right? Let me extend these. Okay, so let me make only this much portion of the beam, this much portion here. Okay. There are certain ways with which you can actually work out the moment at this particular point, this particular section in fact. So let me just write this as simply mx, right? And then there is this UDL, very small portion, okay, till here. That's the UDL, and then there is this point load. Right, and then there is this RA. We already know the value of RA. It's known to us. Okay, we have calculated it, and this is, let me just plug in all the values. This is 20 kilonewton. This is also 20 kilonewtons. Make sure that we are doing the entire mathematical analysis using kilonewton. So some kind of conversion has to happen at the end. Okay, in framing the final slope and deflection equations, in fact. And apart from that, we've also got this UDL. The magnitude is 10 kN per m. In 1 meter, the load acting in the downward direction is 10 kilonewtons. Okay, so essentially this entire distance, well, that's x. That's x for you, right? And then secondly, this is 1 meter. This also is 1 meter. Don't worry, everything will happen, everything is going to fall in place. What do you want? You want moment, right? Moment right here at this cross section. So whenever you take the section from the left, always just put there an anti-clockwise moment. Okay. Now, you just need to do this. Moment about a certain point is equal to 0. Let's say this is that point. Let me write O over here. O. So when you take the moment, what's going to happen is this, mx, okay, since it is anti-clockwise, take it in the positive sense, then 20 multiplied by x, this is clockwise, minus of 20 into x, 20 multiplied by this much distance. How much is this? This minus this is this, x minus 1 is this, x minus 1, in fact. So anti-clockwise, a positive sign, 20 multiplied by x minus 1, and that's it. And finally, you've got to deal with the UDL. That's also very interesting. You've got to take a look at this very, very carefully. Very carefully. Okay, just take a look at this. Just take a look at this. This distance I'm talking about. Can you work out how much this distance is going to be? If this is x and that's 2, so that's x minus 2. Got to be very careful. Okay, so you can essentially say that the UDL is acting on a span of x minus 2. So if in 1 meter, the total load in the downward direction is 10 kilonewtons, so in x minus 2 meters, it is going to be 10 times of x minus 2, obviously kilonewtons. So So this UDL can essentially be replaced by a point load. UDL can be replaced by a point load like this, and this load is nothing but 10 into x minus 2. So obviously this is anti-clockwise, so a positive sign 10 times of x minus 2. So this is just the force. We need to multiply this with the perpendicular distance in order to get the moment. Okay, so I don't know where to write this. The perpendicular distance is this much. This is that perpendicular distance. And if I were to ask you, bhai, ye value kitna, how much is this value? This is going to work out as x minus 2 divided by 2. This. Half of this, x minus 2. So this is the force, right? This UDL has been replaced by this point load. This point load is having a magnitude of how much? That is 10 into x minus 2. That's force 10 into x minus 2 into this perpendicular distance. That is this over here, x minus 2 by 2. So yeah, that's it. 10 into x minus 2 into x minus 2 by 2. So this is essentially how you can work out the moment, and that's equal to 0. And let me finally frame the moment equation. एक और तरीका है इसका hogging और sagging. I'll demonstrate that also. Don't worry, उससे भी समझ जाओगे आप. That's also quite easy. So you've got the final moment equation. Let me just write that. क्या हो गया? पेन ढंग से लिख नहीं पा रहा है. mx is equal to, okay, so बस sign change करते रहना, keep on changing the signs, right? All of them have been shifted towards the right hand side. 20x minus 20x minus 1, 20x, okay, a separation line. What is the name? AC. Done. Then minus 20 into x minus 1, minus 20 into x minus 1, again a separation line, and that's CD. And finally you've got this 10 times of x minus 2 whole square divided by 2, and here also we are going to have a minus sign. 10 times of x minus 2 whole square divided by 2, and that's it. That's it. So if you are working between x is equal to 0 to x is equal to 1, only this much has to be considered. If you are working between x is equal to 1 to x is equal to 2, that means between C and D, then in that case the first two terms will be considered. And if you are working beyond this point D, that means if your value of x is more than 2 here, that is 3 or 3.5, then in that case all the three terms will be taken into account, or all the three terms will be considered. So this is the philosophy with which we shall be trying to work. Okay, so that's your moment. Anyway, I was just thinking about this as, just take a look at this. Fatafat, let's try to finish this. Let's say you want to work out, and that's the UDL. Okay, then there is this point load over here. How much? Well, the point load is 20 kilonewton, and then you already know that we have this reaction, that is 20 kilonewton. So this is x, that's 1 meter, that's 1 meter between these 2 points, right? What we want is the moment at this particular section. So this can be approached with the help of hogging and sagging. So if it's a case of hogging, then you take it as negative. If it is a case of sagging, you take it as positive. Remember this. Just take a look at this. You want the moment right here because of all these fellows. So you can essentially, what you can essentially do is simply write mx is equal to, keep on calculating. Just take a look at this, 20 kilonewton with respect to this point. X acting in the one, it will bend the beam in this form, isn't it? This 20 kilonewton force is acting in such a way that it will bend the beam in this form, that is positive 20x with a positive sign. It's that simple. Similarly, this 20 kilonewton is acting in the downward direction, and therefore it is going to bend the beam in this form, that is negative, minus 20 into what distance? This distance is x minus 1. And finally, you've got this UDL. So we are converting the UDL into form of a point load. This distance, by the way, it's x minus 2. So this is going to be 10 times of x minus 2. And this is also going to bend the beam in this form, right? So minus 20 into x minus 2, not 20 but 10 into x minus 2, and this much distance is perpendicular distance x minus 2, and it's half. That's it. That is the way forward. Okay, just a second. गर्मी हो रही है आज काफी. Okay, now good to go. So that's it. अब क्या करते हैं? So we have this moment equation, and you know very well this is nothing but ei d2y by dx square. So instead of writing this mx, let me straight away replace this. By e I y double dash. Y double dash corresponds to a double integral, you know, d2y by dx square, and then when you integrate this, you'll have another y, but that is going to be y dash. That represents slope, and final integration will give you the deflection. Let's start. Why wait? ये सबको मिटा सकते हैं. I think you all should note this down, right? Note this down. Here we go. So this is the first time that we are integrating. When we do that, this is going to be e I y double dash will become y dash. This is going to be equal to 20 times of x square over 2. Obviously a constant of integration c1. That's the separation line, that's AC. Okay. Minus 20 times of x minus 1 whole square divided by 2. Again a separation line, that's CD. And finally you have this minus 10 times of x minus 2. This will become cube, and 3 2 is 6. So that is your raw form of the slope equation. We need to again integrate this to get the deflection equation. Let's do that. Okay. I hope every sign is correct. Yes. Yeah. All the signs are perfect. Right. So we're going to integrate this again. And when you do that, this is what you get. E I y is equal to 20x cube by 6, and this is going to be plus c1. Well, that's not alone, c1x plus c2, a line of separation, that's AC. Okay. So if you've got the values of x between 0 and 1, obviously this is the extent to which this deflection equation can be used. And then again we have minus of 20. Let me write small x minus 1 cube, 3 2 is 6, separation line CD, minus 10 times of x minus 2 power 4 divided by 6 power 4, that is 24. Yeah. Let me just very quickly make a check. 20x cube by 6, c1x, c2, okay, minus 20x minus 1 cube by 6, and minus 10 by 24, x minus 2 whole power 4, and this is 20x square by 2 plus c1 minus 20x minus 1 whole square by 2 minus 10 x minus 2 whole cube, x minus 2 whole cube, yes, divided by 6. So these are essentially our slope and deflection, raw form. Right? We need to work out also the values of C1 and C2. Well, they can be done by applying the boundary conditions. So let me just very quickly apply the boundary conditions. So you know very well, it's a simply supported beam, and for simply supported beam, the deflection at the end points, that means at A and at B, it is going to be 0. So at x is equal to 0, compress this, at x is equal to 0, we are right here, the deflection is 0. Let's do this. X is equal to 0, the deflection is 0, that means y is equal to 0. Just take a look at this deflection equation, 0, 0. If you just put this value as 0 over here, 0 minus 1 is minus 1, discard, 0 minus 2 is minus 2, discard. And anyways, x is equal to 0 is in this portion, AC. So for AC portion, we have to work within this range. Okay, you know the deal. And if y also is 0, so obviously you're going to get the value of C2 as 0. That is pretty obvious. Now what? Now we need to think how can we get the value of C1. So C1 can also be obtained. बताते हैं आपको. Watch this. Well, this was the first boundary condition that we had applied. Let us try to apply the second boundary condition. The second boundary condition is at x is equal to what? 4. We are right here. Again the deflection is 0. At x is equal to 4, the deflection is 0. So we need to now frame an equation, and we need to solve that equation to get the value of to get the value of C2. Okay, not C2 but C1. कैसे करेंगे ये तो देखते हैं यार. यहाँ पे इक्वेशन फिर से लिखते हैं, थोड़ा मेहनत करना पड़ेगा. यहाँ पे लिख लेते हैं. Watch, 0. Deflection is 0, right? So that's 0 is equal to. So for x is equal to 4. So we have covered the entire beam. So all of this will be considered, right? Even if you want to check 4 minus 2, it's a positive value. Again, tick mark. You have to consider this. 4 minus 1, again a positive value. 3, tick mark this, and all of this stuff is going to be considered. So that's 0 over here is equal to 20 multiplied by x कितना लिए? 4 लिए. That's going to be 4 cube over 6. Okay, plus 4 times of C1 and C2, you know very well C2 is 0, so don't worry. Minus 20 times of, ये कितना आएगा? X minus 1, that means 4 minus 1 and its cube divided by, what's in the division? Divided by 6, and minus 10 by 24. In the numerator we have x minus 2, that means 4 minus 2 and its power 4, and yeah, that's done. You just need to solve this equation, and on solving you are going to get a certain value of C. अब मैं बता रहा हूँ यार, let me just do a very quick check. 20 to 4 cube plus 4C1 minus 20 to 4 minus 1 cube divided by 6 minus 10, 4 minus 2, 4 divided by 24. C1 will be obtained as minus 21 point minus 29.16. So this is the value of C1 which you will be obtaining. Okay, so I need to cover up a lot of steps, so that is why this is the rough work, you can say. Okay, so we've got the value of C1. This is easily calculatable, not an issue. आगे बढ़ते हैं. So C1 has been obtained. Now these two raw forms can be transformed into the pure forms. कैसे लिखेंगे? चलो इसको लिखते हैं फटाफट. Slope and deflection, right? Slope and deflection. So we need to make some space. थोड़ा जगह बना लेते हैं यार. Here we go. चलो कहाँ पे लिखें? Slope. Let's start with slope. Let's write the slope equation first. So you just need to plug in these values, guys. Nothing. You just need to plug in the values. C1 has worked out as minus 29.16. So just put it up over here. That is the final slope equation. मैं लिख के एक बार दिखा देता हूँ आपको. (20 by 2), that is going to be 10. 10x square plus C1. C1 is minus 29.16 minus 29.16. Anything else? Minus 20 by 2, again 10. Minus 10 times of x minus 1 power 2. हो गया. Minus 10 by 6. So 10 by 6 is 2, 5 is 10, 2, 3 is 6. 5 by 3 times of x minus 2 power 3. Yeah, this is your slope equation. थोड़ा सा इसमें एक मॉडिफिकेशन है, बताऊंगा थोड़ी देर में. पहले डिफ्लेक्शन भी लिख लेता हूँ. Now let's write the deflection equation. डिफ्लेक्शन पूरा नहीं लिख सकते यार, समय ही नहीं है उतना. डिफ्लेक्शन में यार इसका काम में आना है, ठीक है, तो बहुत केयरफुल रहना पड़ता है. 20 by 2 10 हो गया, 20 by 2 ये भी 10 हो गया, 10 10 तो 2 आया, ये 5 2 पंजे 10, 2 3 6, ठीक है. 20 बटे 6 तो 10 बटे 3 बनेगा वो. चलो करते हैं उसको भी. लेट्स डू दिस. दिस इज गोइंग टू बी E I Y is equal to, here we go, 20 by 6, 2 10 is 20, 2 3 is 6, 10 by 3 x cube. So this is going to be 10 by 3 x cube. और कुछ C1 is minus 29.16 times of x, minus 29.16 x. Okay, what else? C2 is 0, not to worry, बिल्कुल टेंशन नहीं. minus 20 by 6 तो ये भी 10 बटे 3 होगा, ठीक है. 10 by 3 minus 10 by 3 x minus 1 cube. Done. And minus 2, 5 is 10, 2, 12 is 24. So minus 5 by 12. Minus 5 by 12 x minus 2 and all of this to the power 4. Okay. फटाफट एक बार मैं चेक कर लेता हूँ क्योंकि एक बार भी कहीं मिस्टेक हुआ 10x स्क्वायर, ठीक है, किधर गया 10x स्क्वायर माइनस 29.16 माइनस 10x माइनस 1 होल स्क्वायर माइनस 5 बाई 3 x माइनस 2 होल क्यूब. बिंदास. ये जरा देखते हैं, ये आ रहेगा 10 बाई 3 x क्यूब, 10 बाई 3 x क्यूब माइनस 29.166, ठीक है, माइनस 10 बाई 3 x माइनस 1 होल क्यूब, ठीक है, माइनस 5 बाई 12 x माइनस 2 होल पावर 4, बिल्कुल ठीक है. I just forgot to make those separation lines now. Let me do that. So the first separation line is going to be right here. That's AC. The second separation line is going to be here. That's CD. AC, CD. Yeah, that is enough. That is enough. Now you have the slope equation, you have the deflection equation. You just need to plug in the values and get the maximum deflection at C. And for getting the maximum deflection at C, not C, I just need to check whether it was C or D because I swapped them. C पे निकालना है कि D पे निकालना है. So this is supposed to be calculated at D. Okay. Although you can also calculate the deflection at C as well. Not an issue. Go ahead and calculate. Okay. So this is essentially going to be our first part. First part of all the stuff which is supposed to be calculated, and let's begin. Why wait? Deflection at D. Deflection at D. Now if you are at D, that means x is equal to 2. It's pretty obvious. That means x will be equal to 2 meters, and that is the value of x which we are going to plug in into this equation. Okay, one more thing I forgot to tell you. So not before, but as we began, I told you that all the forces which were given to us were in kilonewtons, isn't it? Right? So we need to convert them into newtons. Or what you can do is over to this side, the unit running is kilonewtons, you can say, in terms of kilonewtons, you can say. So here also it needs to run in kilonewtons. How are you going to ensure that? Well, watch this. Obviously, you need the value of E into I. Okay. So E and I, the product of EI, this is going to work out as, let me just see, 200 gigapascal. This is nothing but 200 into 10 raised to 9 multiplied by I is 20 into 10 raised to minus 6. So when you do this multiplication, just very quickly make a check. 4 into 10 raised to 6 Newton meter square. 4 into 10 raised to 6. Okay, so this is going to work out as 4 into 10 raised to 6 Newton dot meter square. So somewhere here we have the unit as Newton and here we are having kilonewton. So this is an aberration. कुछ गड़बड़ होगा. बैलेंस करने के लिए क्या करेंगे? न्यूटन को अगर कन्वर्ट करना है किलोन्यूटन में, if you want to convert newtons into kilonewtons, okay, like this, what you need to do is you need to divide by 10 raised to 3. So here also and here also we are going to divide it by 10 to the power 3, here as well 10 to the power 3. Now the equation appears balanced. Now we can move forward and apply these equations. You just need to plug in this value. X is equal to 2 meters into this equation. दिखाता हूँ मैं करके कैसे होगा वो. फिर पसीने आ गए. आज तो पसीने ही छोटे जा रहे हैं. एक मिनट. चलो बढ़े. All right. X is equal to 2 meters. चलो वैल्यू पुट अप करते हैं यहाँ पे EI, in place of EI I can replace it with 4 into 10 raised to 6. छोटे छोटे वैल्यू लिखते हैं 4 into 10 raised to 6 और नीचे डिवाइडेड में denominator we already have 10 raised to 3 multiplied by the deflection where at point D. We need to find the deflection. Over to the right hand side. You're finding the deflection right here. That means you're in portion CD. So if you're in portion CD, only the first two terms will be considered. Okay, before this separation line, that is supposed to be considered. Only this much. Even if put the value of x is equal to 2, accepted 2 minus 1 is 1, positive value, accepted. 2 minus 2 is 0. So even if you plug in the value, you can also work it out from that perception. So this is going to be 10 into 2 cube by 3, right? Minus 29.16 into 2, और क्या आएगा यहाँ पे आएगा minus 10 into 2 minus 1 cube divided by 3. So that is the equation which you need to solve to get the value of 5D. मैं चेक करके बता देता हूँ 4 into 10 raised to, ठीक है, everything seems perfect. So on solving this equation, what you are going to get, let me just tell you. कुछ सी और पेन से लिखें क्या, लाल से लिखते हैं. The value of YD which you guys are going to get. Minus 8.746 minus 8.746 into 10 raised to minus 3. This is meters, and obviously it's a very small quantity, it's a very small distance, so it is better and it is appropriate that we write this in millimeters. बस नेगेटिव साइन, बस आपका जो डिफ्लेक्शन है वो डाउनवर्ड्स है, उसको शो करने के लिए. सो दिस इज गोइंग टू बी माइनस. अब हटा दो यार, हटा दो. बिंदास लिखने का इसको 8.746 10 to the power minus 3 can be replaced by a milli and then followed by a millimeter, a meter rather, and that's it. And deflection is where? In the downward direction. That's it. बस ऐसा करके लगा लो. Here we go. So that's done. So this portion of the problem, it's done and dusted. Now guys, the second thing which we need to work out, again this is also fairly interesting. Just take a look at this. What we need to work out is the maximum deflection. And by now, if you've seen all the lectures of deflection of beams, you should have realized that maximum deflection will be obtained where the slope is 0. Wherever the slope is 0, that is the point corresponding to which you are going to get the maximum deflection. Okay, let's begin. What? Maximum deflection. क्या हो गया इसको? अब ठीक है. X is equal to, we don't know yet. Okay, we can work it out very easily, right? So let me just have a discussion with you. Obviously the beam is going to bend. Initial position of the beam is something like this. The beam is going to bend in this fashion. So this is point C and that's point D. So obviously the maximum deflection will happen between C and D, and wherever that happens, if you try to draw a slope, that slope will be equal to 0 because it is absolutely horizontal. If it does not make any angle, that means it is absolutely horizontal, and which corresponds to 0 degrees, you can say, okay, or 0 radians, let's say. Now what we wish to do is between C and D. So between C and D, okay, let's say we are working between C and D, then in that case this slope equation we have to consider only this much. Let me just write this. Let me write this once and then you will understand. 10x square and this minus 29.16 and then with this minus 10 times of x minus 1 whole square, and all of this is going to be equal to 0. Once again, we can actually realize that the deflection is going to be maximum bit somewhere in between C and D. Okay, so wherever the deflection is maximum, slope at that particular point will be absolutely horizontal, or mathematically you can say slope is going to be equal to 0. So that's exactly what I have done. Between C and D, if you are working between C and D, then you have to consider only this much portion of the slope equation, So that is 10x square minus 29.16 minus 10 into x minus 1 whole square is equal to 0. So this sort of is a quadratic equation, and let me just make a check. 10x square minus 29.16 minus 10 times of x minus 1 whole square. You just need to solve this equation, just plug it into a calculator. Okay, simplify this and plug it into a calculator. The final value of x which you are going to get, let me just write this, x is equal to 1.95 8 meters. That means here at D exactly it is 2 meters. So just before D you are going to get the maximum deflection, and that's exactly where the slope is going to be equal to 0. Okay, so let's finish it off. Right, so again it is just before D, and again in the deflection equation also you have to consider only these terms. Even if you put the value 1.958 over here, this inside the bracket will return a negative value, and obviously you have to discard it. That is the Macaulay's approach. So let's do this. EIY, what is EI? EI is nothing but 4 into 10 raised to 4 divided by 10 raised to 3 multiplied by y max is equal to, let's do this, 10x cube by 3. Okay, 10x cube. So 10 into 1.958 cube, 10x cube by 3. Once again 1.958 है ना, हाँ ठीक है, 1.958. Then we've got this minus 29.16 into 1.958, done. And you've got this minus 10 times of 1.958 minus 1 and its cube and divided by 3. Okay, so that's it. You don't need to go further. Even if you go, as I've said, this will return a negative value. 1.958 minus 2 will return a negative value, and negative values have to be discarded. Okay, so that's it. You just need to solve this equation and get the value of y max. Let me tell you how much that will work out is. Y max, the maximum deflection which would happen, is going to be equal to, where are my notes? Okay, the PDF file to these notes can be accessed from the description. मिल जाएगा आपको नीचे. ये पहले अच्छे से समझ लो. कितना आया? Minus 8.751 into 10 raised to minus 3. Let me just check the equation once. Okay, minus 10 by 3. Yeah, perfect. Minus 8.751 into 10 raised to minus 3. Minus 8.751 into 10 raised to minus 3. So guys, this is in meters, and obviously you better to write, this is a very small value, so small values should be represented by millimeters. So let me just write this, 8.751 millimeters where in the downward direction. That's it. Here we go, that's done. Finally, in the final part of the problem, what we need to do is, we need to find the slope at A. This can be done fairly easy. It's not that tough. Okay, थोड़ा सा यहाँ पे मिटाते हैं. कहाँ गया डस्टर? कैसे? Here we go. यहाँ पे. What are we supposed to calculate? Number 3. 1, 2, 3. What are we supposed to calculate? We have to find the slope at A. At A. And this essentially is nothing but theta. What? Theta A. So theta A is supposed to be worked out. So this y dash over here, that is nothing but the angle in radians. Okay, always remember, that is the slope, that is the angle in radians. So we कैसे calculate करना है slope at A? We have the slope equation. Okay, so obviously if you want to find the slope at A, compress this x, and x is going to become 0, because at x is equal to 0 we have A. So obviously this is the first condition which we need to apply. X is equal to 0. So when you put the value of x is equal to 0, that means you are in the portion AC. If you are in the portion AC, only this much portion will be considered. Only this much portion, right? Only this much portion. In that also, if you put x is equal to 0, this is going to become 0. करके दिखाते हैं आपको. EI y dash. Okay, so the value of EI we already know, 4 into 10 raised to 6. 4 into 10 raised to 6 and divided by 10 to the power 3. And then you've got the slope. This slope, theta at A. Okay, slope at A. 10x square minus 29.16. So is equal to 10 into x square, that means 0 square minus 29.16, and that's done. You just need to solve this equation, and let me tell you, theta A in radians, let me tell you, theta A will work out as 7.29 into 10 raised to minus 3 radians. If you want to do a conversion, you can surely do that. In degrees, this is going to work out as 0.4176 degrees. So if you want to reach here from radians, you just need to multiply by 180 over pi, and pi basically is nothing but 22 by 7 or 3.14, right? So this is essentially how you can work out a problem where you need to deal with a uniformly distributed load and also a point load. That's the idea. Okay, one final check. Okay, everything is perfect. Everything is perfect. That's it. So yes, please note this down. If you don't want to note, you can access the notes also. So guys, that was all for today. We'll be doing some more problems on Macaulay's method. They will be uploaded very soon, don't worry, everything will fall in place. That was all for today. I'm going to see you again in the next video. Until then, take care, have a nice day, keep learning, keep watching. Thank you.